how many elements does it have in it? 2 or 3? It's got 2. So if it's got 2 elements in it, what are we going to do to it? We're going to break it apart. So what 2 things does it break apart into? Cr plus Cl. Now, if there are 2 elements, what do you ask yourselves? Are they diatomic? Are either one of those elements diatomic? Cl is diatomic. So what do we do to the Cl? Out of 2. Now, is it balanced? No. Nope. So the only thing that's not balanced is the Cl, right? How many are here?
6.
How many are here?
2.
So what am I putting here?
3.
Voila. Questions? Yep. It's the ones that have 3 that cause the issues. Now, if you have 3, okay, so what can you tell me about the next one? Jade, do you want that phone up there behind my desk? And leave it alone. So when you look at the next one, how many elements do you have?
2. Well, you have element
So yeah, but how many elements do you have?
3.
You got 3. So can we just split it apart? Now, don't write this down, but some of you on the test Monday will do this. CO plus ClO3, and I will come along and write -4 and keep going to the next question. Okay? Because a lot of you in here, Tiffany's over there stickering. All right? A lot of you are going to do this to me. And I'm just going to write -4 and go on to the next question. Okay? It's wrong. Whenever you have 3 elements, particularly for those of you who were not here yesterday, where did we say we would look if we had 3 elements? On the reference sheet. So those of you who weren't here, find your blue reference sheet. Okay? There's a whole section on decomposition on page 6. You have to find the equation that matches decomposition to that equation. So when you look at it, which one best matches COCl3 under the decomposition section of this one? Metallic chlorates. So I'm going to write MClO3 becomes what? MCl plus O2 right below it. Now all we have to do is make this fit that. So what goes in the M spot? Well, what metal is right here? So I'm writing CO. What element has to go with it? Cl plus what? O2. Well, the O2 is taken care of. We don't do anything to that. The COCl is a compound. What do we always do to a compound that I've been railing about for days? We have to crisscross. So we need cobalt's oxidation number. Where do we get cobalt's oxidation number from? No. It's in the equation. Look right here. What number came from cobalt? Right there. +3. So cobalt had a 3. Because if you look on the oxidation sheet, which some of you undoubtedly did, and you look up cobalt, you go, cobalt over here has a +2 and a +3. Then you look back up there and go, dang, cobalt has a 3 there. I must use the 3. You can do that every time. You're just wasting your time. All you had to do was look where? Right there. Cobalt has a what? A 3. So, what's chlorine's oxidation number? -1. Bring my 3 down. Bring my 1 down. Okay? Now, is it balanced?
No.
Nope. So, what am I going to do to balance it? Okay. So, how many CLs are here? There's 3 CLs there. So how many CLs there?
3.
Those look good. Okay. Oxygen has how many?
9.
How many are there?
2.
So can I get 9?
No.
So what am I going to put there?
2.
It's all right. Make it an even number. So I made how many?
18.
Okay. How do I get 18 here?
9.
Okay. So how many COs did I make?
2.
So what am I going to put here?
2.
Voila. Questions? Yes? No?
No.
Okay. What can you tell me about Ag2CO3? Okay. How many elements do I have?
3.
I have 3. So anytime I have 3, where do I look?
The
The reference table. Okay. So if I look at the reference table, which one of these trusty little formulas looks just like Ag2CO3 under decomposition? Metallic carbonates. So MCO3 becomes MO plus CO2. Okay? Everybody with me on that? Okay, so it goes with the M. Ag. And then O, and then plus CO2. All right. What oxidation number does Ag have?
3.
Okay. That and parentheses. I just left them off. See if I can throw y'all off. That's a 1. It's a +1 and a -2. So +1 -2. Bring your 2 down. And then that is already written, so I'm not doing anything to it. Okay? So get rid of those. What do I need to do to balance?
Nothing.
It's balanced. All right. What kind is number 4? If you've already done it, you figured it out.
Oh, it's a synthesis.
It is. Most people probably didn't figure that out initially, did they?
No.
No. What did you think it was initially?
It could have been.
A lot of people probably thought it was double displacement. So let's do it as double displacement for those people who weren't here yesterday. So if you thought it was double displacement because it's a compound plus a compound, what's the first step in double displacement for somebody who wasn't here yesterday? What would you do if it was double displacement, Jonathan? What's the first step in double displacement? Not a trick question. You forgot. So if it was the first step in double displacement, find the oxidation numbers, right? So +1, -2, +1, -2. What's the second step in double displacement? You remember that one? Switch the. Okay, so who would you switch?
Li.
Sure. All right. So Li would be with O and H would be with O. All right, Jade, what would be the next step after we switch them? Yeah. Yep. So +1, -2, +1, -2, and put them in. What'd y'all find out? What happened? We got what? The same thing. When you get the same thing, that tells you it's not what? It's not double displacement. Okay? So if it's not double displacement, what is it? It's synthesis. So look at synthesis under your blue reference table. Okay? It's not an A plus B. So that only leaves you the two choices of B and C, right? So it's not. This is a what? Is that a metal or a non-metal? It's a metal, right? All right. For those of you who were not here, see how it says you make a base right here? You can write on your table for one of the few times you get to. Beside base, write M parentheses OH. Okay? Beside where it says base, write M parentheses OH like I just did. See how I wrote that? M-O-H. Put it down. Okay. Everybody got it? Because I'm going to erase. So you get to make a compound here, which is a what? What does it say you're going to make if these two things react? It says you're going to make a base, right? So you need an MOH. What's the metal? Li. And then it's with OH. Is that an element or is that a compound? So what do you have to do every time you have a compound? So +1 and -1. Bring your 1 down and your 1 down. They cancel out. And all you need to do is balance it. Is it balanced? So you got 2 Li's. I'm going to put a 2 there. 2 O's, 2 O's, 2 H's, 2 H's. And now it's balanced. Questions? No? Fabulous. Most fabulous. All right. Do we look at homework? Okay. I think it's this one, but I can't swear to it. Yeah, I think it's this one. That look like the right equations?
Yeah.
Okay.
Yes.
Check your answers. See what you got for those of you who did it. All right. Is it time to turn the page, or are we still good? Still checking. Anybody still checking? Give me a wait. Where are we at? Other than Samari, who keeps telling me to turn it, is there anybody who needs me to go or wait? You know, because she's kind of vocal over there. So if the rest of you need time, you're going to have to speak up for yourselves. Okay? And that's a typo. That's a 2 I forgot to put there. The little 2 is there. Okay? Now, if you forgot any subscript, the answer is wrong, and on a 4-point question on the test, you will lose at least 2. Odds are good the subscript will cost you more error, and it could cost you 3 or more points on your test question. This is the biggest bulk of the points on your test Monday. Not the only section, but it is the biggest section in terms of points. The section probably makes up 50 to 40 of the points. The other sections add up to make up the rest of them. All right, where are we at now? Everybody had a chance? Got any questions? Anything you want me to do? Work, solve. Because I see some people writing some stuff down. So is that I was out yesterday and I'm just writing the answers? I got something wrong and I need help? Or I taught it so well I'm ready for the test this well, I got this. Sure, I can do 7.
You're welcome, Darlene.
They pay me to answer questions. That's my job. This morning I spent my morning tutoring some college kid. All right, so C6H17 plus O2. I can't get any of y'all to ask me questions, so I got strangers coming off the street getting help now. C6H14 plus O2. So, what kind of equation is it? 7.
It's combustion.
Are we okay with that, Darlene? So what are my 2 products going to be?
Carbon dioxide and water.
Okay, so I write CO2 plus water, right? All right, so what element are you going to balance first? If this is your test question on Monday. Okay, how many carbons? So what you putting here? No. That 2 only goes to the oxygen, okay? So we're going to put a 1 right there to remind you that that's a 1. So you're going to put a what there? Okay, let me change my color. All right, so we're going to put a 6 there, okay? How many H's you got?
14.
So we're going to put a what here?
7.
Okay, 7. 7 times 2 made 14. Now the hard part, we got to count our rows. Okay, so 6 times 2 is how many? Okay, 7 times 1 is?
7.
So 12 plus 7 is?
15.
19. Can I get 19 there? No. Okay, so I'm going to get rid of that. And then I'm going to erase there and there. And what am I going to put right here?
2.
Okay, 2 times 6 is how many?
12.
So what am I going to write here?
12.
Okay, 2 times 14 is how many?
28.
So what am I going to put right here? Okay. Now, the hard part. 2 times 12 is how many? 24. Plus 14 times 1 is how many?
20.
Okay, you're multiplying the H's. We're doing the O's.
14.
14. Okay, so 24 plus 14 is how many?
38.
Guys, we got 38 oxygens. We need 38 there. So what times 2 will give me 38? Use a calculator on the test. Huh?
I don't know.
I got a whole box of them. So, to quote third period yesterday, they said, Miss Wall, should we get a calculator on the test? I said, yes. They said, should we get one before the test? I said, yes. That way you don't have to slink over there and get one in the middle of the test and feel like, oh, I'm stupid because I need to get a calculator and somebody's going to know I can't multiply or add. So just go ahead and get one before the test. So if you need it, you can just discreetly and calculate, and nobody knows. And then you just put it back at the end of the test. Nobody knows you needed it to multiply or divide or add, okay? Nobody is wiser, okay? But if you have to ask in the middle of the test, can I get a calculator? Or you got to slink over there and get the calculator. Everybody knows you needed a calculator, okay? So just get one at the beginning of the test. Nobody knows. Will that work? All right, so what number there will give us 38 oxygens? There you go. What other questions would you like for it? Because I know sometimes it's about not wanting your peers to know that you needed something. You don't want anybody to know. Yes. What?
But, you know, I feel like number 5, once you like separate it on the other side and switch the AL and the MG doesn't get a number, does it? Oxidation number.
No. So I would, just to be on the safe side, I said earlier, you don't always have to use the oxidation number. I think it was Tiffany who yelled this out a while ago. She yelled 4 on something or 3 because she just backwards crisscrossed. Look up the oxidation number if you're not sure. Double check yourself, right? So Mg has an oxidation number of +2 when you look it up. There's not 2 in that formula, is there? No, there's nothing wrong with looking it up. Be on the safe side. Check it out, okay? Sulfate has what oxidation number when you look it up? -2. What happened to those 2's? I canceled out, right? So we know the oxidation numbers. Aluminum is a +3. I would even go so far as to draw my parentheses around there if I needed to, so I knew it was a what? It's a polyatomic ion, just to be on the safe side, so I know what it is. So when I switch, I know I have aluminum with SO4, and then Mg is by itself. Most people will not have any trouble saying +3, -2, bring my 2 down, bring my 3 down. It's the magnesium, like you said, that's causing the issues. Is Mg one of the 7 diatomics? So you don't do anything to it. A lot of people like to say, oh, it has a +2, and they want to bring that 2 straight down. We can't do that, Okay, Mg is an element by itself. Is it one of the 7 diatomics? No, it gets absolutely nothing. Okay, and that's hard, particularly in a question like, let's say on the test, I write iron 3, and I put a Roman numeral behind it. Then it gets even harder because I wrote Roman numeral 3. People want to put what on that iron? They want to put a 3 behind it. It doesn't get a 3 at all either. It's a Roman number of 3 because when you have it on the product side, when you need to crisscross, I have to tell you what Roman number to use. That's why I had to tell you it was a 3. I had to give you that. But that doesn't mean you stick it on as a subscript on the reactant side. It's just there because you need it down the road in the problem. Okay? It's by itself is a diatomic. It gets nothing. The only elements by themselves that get a subscript are those special 7. Nobody else gets a subscript. Okay? Anything else in the homework? Yes? No? Okay. We're going to practice a little more before we move on to the activity series. All right. All right, we're going to work. You get another check and we can work on that. All right, you're predicting products. You got to write the left side and the right side this time. I didn't put anything in symbol form. About half of the middle section of the test are like these, where you have to translate into symbols first, and then you have to predict the products. Okay? You can use your blue reference table. I tried not to make them real hard. I'll let you get started before I come poke around and look over your shoulders and be a general nuisance. So let's say this was the test. You're gonna get that, and that, and then put another arrow here. I would use both again, another arrow. Give it up. Okay. Good. To the next one. Again, have you got another arrow going? Give her that thing. All right. So crisscross here and finish that. And then what kind of reaction is it?
The reaction.
Yeah, it's a single, double, decomposition, combustion, or something. Got a plus sign?
Yeah.
It's not added.
Well, I gotta-
Don't fall into that, Ted. I'll get it in a minute. I'm not really- I was gonna get it out of there. So when you look there, which one does it look like? Is it just two elements? And then it will be that one, and you're gonna do what with it? Flip.
So that's it, just split?
Yeah.
Is this one like a switch on?
Now, you see how you've got this?
I didn't balance.
I know, but see how you're doing that? Write it all together instead of just lumping it and trying to make a shortcut on the test next week. I like to be super lazy and then balance. All right. What you gonna do with those two twos that you brought down? Yes. Exactly. That's what you got.
Whatever.
You know, I have to, I just mark it wrong on the test one. All right, see how you put this here, and then put a plus sign there, arrow out here. All right, see how you put that two right there? You know about that, don't you? Anything special about it? Thank you. How are you? You okay? Yeah. And this side, there you are. What's wrong with number one? Crisscross your occupation numbers. All right, what is your neutral? Okay, decomposition. Which one does that look like? Out of those choices, which one does it look like? How many capitals do you have? Which one has two capitals? That one. So what's it doing? Okay, you know anything special about either of those elements? Really? Or even those setback elements? All right. Yes, look, I want you to do this. Oh, here. So, it was. Stop your brain. So, when you see an element by itself, you're going to say, oh, that is a two. What kind of reaction is this? Hmm? Number two. Yeah.
Fix that next year.
Hold the roll. All right, you see how you crisscrossed over here? Crisscross there. Three down. Okay, do it. And over there is great. And over there is great. You forgot to crisscross and bring it down to here. Do the same thing on this. 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 All right. What's wrong? Alright, I'm almost positive two, your overview is too low. In my head, that's 40, that's 22, that should be 62. Well, that should be 31. My dash is up. Like I said, that's just a quick scan, the rest of them don't have. All right, what you got going on here? All right, so that's SRCl2, right? Now an arrow. What kind of reaction is it? Mm-hmm.
No,
All right, so which one of those does it look like? Okay, so it's A saying to do.
so AB equals A plus A.
So that's just saying to do what with the AB? So right triangle plus square. All right, these are elements. What do you ask yourself if they're elements? Are either of them diatomic? So what are you going to do to it? Voila. Now, this one is combustion, right? So what are the two products in that one? Well, that's what I gave you. So you're going to write your C10, H22 plus, how do you write that off? And what are your two products? So you're going to write that part. And then what are the two products you get?
Carbon dioxide plus water.
So write carbon dioxide plus water.
So basically, this has a two, so we can go.
Yes.
Yeah, that doesn't matter.
I don't like occasions. I would buy my son, and that's really hard because it pisses me off. So, now this one. Yes, keep going. You're doing fine. All right, what you got over there? All right, you balanced two wrong because you got the same problem I want you to do over here. I got a desk to write on. Same thing I told Karen. I want you to write Hector, now, ohms, 5, liter, round, iguanas at the top of your paper. Because, you see this over right here? Diatomic. It's a 2-1. Because without that 2, you're going to balance the equation wrong every time. Okay? Because that's got to have 2 So you need to go back and recalculate. So you got 20. That has a 1 there. So now we need to put what here? That's good. All right, so how many O's do we have here? Okay, plus, how many O's? 40 plus 22 is I get 62 there if I got 2.
Thank you.
Okay. Now.
Big things going on.
So I'm just going to balance now that I've reduced that. All right. This is fine, and then your oxidation numbers in these formulas. What's the oxidation number here? Your sheet. Okay, sulfate is. Okay. That's a 3, that's a -2. What's over here?
So let's figure 2, that's 3.
Yeah, you missed that?
Yeah.
So this at 3, and this at 2. So if that's a 3, that's a 2, what's that gonna be? This is one you drew a question mark at. All right, what's antimony? Chlorine is a what? Quarter.
You're on break.
Oh, wow. Oh. Okay, that's it.
All right, this has what?
What?
Sulfur is what? So 2 comes down, so 1 comes down. Okay, you did this one, 5 and 2, but silver was 4, you did 1. So why that 2 didn't go there?
They can work.
Oh.
Wait, next question.
I'm waiting for
Get rid of that. You're ready.
Okay. Oh, what is it? Yeah.
This one?
Check me on that too.
There you go.
It's gonna help throw that one off. Okay.
What am I supposed to do with it?
It's still hydrogen and polyatomic.
Okay.
Where'd that 2 come from?
That came from the, yeah, that's what we got.
Still a first element in a polyatomic.
Okay.
Nothing changes. Every time you forget that, I'm gonna whack off. See, reduce there, just reduce, cancel them out beautifully. Why can't you do it on that?
Oh, that's right.
Nothing else jumps out at me.
Yeah.
Wait, this is all.
Notice.
Like,
The C.
No, because it's not by itself. This is when they're by themselves, like that's by itself. That's by itself. When they're together with something else, you crisscross, this is compound.
That's where I got the 2. It's okay.
How do you think you did? Why do you think you did that? You cancel because they're the same. Cancel because they're the same. You crisscrossed your 2 and 1. You crisscrossed your 1 and your 2. You need to balance it. It's done. It's done correctly. You just gotta balance.
That's right.
You have some ability here, ding-a-ling. Stop doubting yourself, okay? Yeah, I know. It's brutal here. Okay, pick a polyatomic guy. Pick one. Which one do you want to balance first? Okay, so how many ClO2s are here? Okay, how many are here? None would be one. If there were none, wouldn't be there. So one. Okay, so we need two on that side. So how are we going to get two? Okay, let's put a two there. All right. How many NAs did you just create? How many NAs on the other side? Okay, so pick a different, something we haven't balanced then. No, that's fine. All right, they're just already balanced. We need to check the other two things we have to talk about. So you still have to talk about lead and that Cr2O7. So pick one of those. So like, how many Cr2O7s? How many Cr2O7s? So those are good. How many leads? How many leads? So it's done. Okay. Okay, how about you? Right here. I'm not going to need help.
Oh.
Here's your oxidation sheet when your blue stable carbon sheet. Thank you. You got it. All right. So this is what kind of reaction?
No.
Is that one side?
I just wrote the beginning part.
It's
That's
not
all I
safe if it has no fluff.
And I feel like you want to.
It's the only kind that has no
So
fluff.
yeah, this right here.
You
Come over here.
No, they don't all got this.
No, I told you I do it. Anyway, so if you have that, you have the two right
Now look
there.
at the toxicity composition. This is not It's the only kind.
That's, I know, that's what I thought, but I wasn't. That's what I kept doing too.
Binary compound?
Yes.
It's
So
a
what's
binary.
binary compound?
Think about it like this. AB, arrows, and A.
So what are you gonna do with this to make it A plus B?
SR plus CL.
So you're going right. SR plus CL. And why'd you stick two on?
Because
That's why. Now, you only need two on the tip, like I told several people, extra. Now, ohms, 5, clear, brown, plus. Okay? These are elements by themselves. If they're one of these 7, and they're by themselves, they get a 2. The only reason they get a 2.
so it don't matter what they are.
It does not matter what their oxygen, alcohol. So, are either of those, one of those 7? Which one? And we put a 2 on it, and that's the only reason it gets 2. Okay? We don't care where the oxidation numbers are, I'm not looking them up, doesn't matter.
Why are you doing oxidation numbers up there?
If they're a compound, then we crisscross them. But see, they're not compounds, they're elements. All right, this one you wrote, other than I'm just gonna transfer this CO2 plus water down here so it's all on one line, and you need to balance that. All right, this one we got written, doesn't even finish it. What kind of reaction is it? What's this thing? A compound or an element? What's this thing? What kind of reaction we learned had 2 compounds?
Double, like,
That's right. So we're going to do double displacement. All right? So double displacement means you switch to 2 positives. Now, you see these 2 little 2's right here? What are the 2 little 2's supposed to do? We're not even going to bring in 2 little 2's down. We're going to get rid of them. Okay? So,
okay.
you got +1, -1, +2, -2. Who switched?
Yeah.
All right, so right, here you got your house. Write down what we're going to do on that side.
Okay. But, okay, I have a question. But that doesn't go with that, does it? Or does?
No, it just
It
goes
just
with
goes
that.
with this.
Okay, now, these are compounds, right? Now, we don't use these because they're not important, because we don't have the elements. Now, use your oxidation sheet, put in their oxidation numbers. Or you can do laser man play like me. See how you write those oxidation numbers right there? Put them in right there and crisscross. Yes, sir.
Wrong.
It's not balanced right in that pocket. So you got 15,000. You got 5 and 2, that's fine. 5 phosphates, 3, and you switched them, so you have 5 there for manganese. No, that's a 7. This is a 7.
Got 2 water down.
That says 7. There should be a 7 there. That should be a 7 there. So then 3, 5, and 2. Correct, rebalance. All right, Jay. Oh, you gotta do the balance now. That's correct. Go back and balance. All right, so you want to do the same thing here. This is a compound,
Yeah, that's
right?
right, it's just, I
So
feel
let's
like I'm like,
lose oxidation.
+3.
Plus 3 at the top. So 3 comes down, 2 comes down. This, you wrote plus 2 out, right? What's that say right there?
3.
You're gonna put plus 3 here.
Confused me. Confused.
I'm serious, all right, this is the curriculum. Now,
Put this class.
this single or double displacement, so this is decomposition of
It's a single replacement.
It is. So it works just like double displacement. Except this time, you only have one choice of who you can switch. We're switching this time.
Then the SO4 and FE.
Our switching are gonna be together.
How are they gonna be together? Ain't no +2 and a
That's a
+3.
plus 3. That's a plus 3. That's a minus 2. Remember, the two that have the same sign switch. So the 2 positives are gonna do what? Switch.
yeah,
Good. That's compounds, what do you do?
Bring on.
Okay, bring the oxidation numbers over and switch.
Because, the FE has
That's so bad.
Where? No, this is by itself. Check that off.
Oh,
This is by itself. Is it one of these? It's not. Okay, it doesn't need oxidation number, doesn't need anything else. That's how you do that.
Oh,
Anybody else have a question? We're gonna go ahead and move on for a little bit.
can you come over here and make sure I'm doing this
Right here. Sort of enjoying my seat.
Oh, I feel like I'm doing it wrong because everybody else is shrinking.
Doesn't mean you're doing it wrong.
So I'm kind of confused a little bit on some stuff.
Alright, so there's 3 right there.
FE and so
No.
plus AO.
It's not one by itself, it's not 1 7, it's nothing.
SO4.
Take that off and rebalance.
Okay. Didn't they do it?
That should be fine. That should be fine. That should be. That should be 2 there. This one is 7 diatoms.
So, because that one's by itself, it doesn't have.
That's right. Okay, it's not 1 7 diatoms. That's got 3, that's got 2. That's got 3 there. That may be balanced, okay, but since I put that three right there. Oh, that's just way out there, okay. All right, that's fine. I didn't realize that that way out there was that three. You're fine. All right. Those are both negative. All right, even though that's an acid, it's still a compound. That'll be plus one and that'll be minus two. That should be
Yeah, I was
okay.
gonna do it on this one, but I didn't know what to do.
What, this one there?
Yeah.
Okay. Any acid is still like H2SO4. It's polyatomic ion and an H. So that two came from up there. That's plus one.
That was confusing, that was this one, so I didn't know that.
7, 2, 5, 3. I'll get 5 and 2. I'll get 7 and 3. Yeah, just balance it.
It was hard,
It is hard. I'm aware of that. Just keep playing with it.
What the last one?
yeah, did you find that? You did?
Don't tell them. Let them work on it for a minute.
Yeah, I stopped working on that one tomorrow.
Don't hurry.
Is this it?
Yes. All right, if you will, find a stopping point. What you haven't gotten finished is going to be homework tonight. Not mine. Okay. All right. I want to move on and talk about the activity series because I do not want to teach anything tomorrow the day before we have the test. I want to be able to review tomorrow and practice before we have the test, not teach new stuff. All right, let me find my notes that go with the activity series because I need that chart. Let me say cancel on that for right now. That's not. All right, we're going to talk about the activity series for the rest of class. Now, what you didn't finish on that sheet is homework tonight. Those of you who got all 12 done, you'll have less homework. Those of you who only did 5 are going to have more homework. Those of you, this means you work slower. Monday, you will get the entire class period to work on the test. Test only has, I think, 36 questions on it. It's not a very long test, but some of you will need the entire hour and a half plus a few more minutes to do the test. Okay? Yes, I've got 2 things I'm going to give you tomorrow to study for the test. The only thing that's not on my review sheet is the what that I told you most of you would get wrong because you won't study. Anybody remember? The what? Well, yeah, some of you will get that wrong too, but that I've been telling you for weeks. What did I tell you is on the test? Most of you won't remember from the first day and you won't study. Okay, I'll let you figure it out.
Was it combustion?
Nope. I'll let you figure it out. Now, for those of you who like titles, this is called the activity series. All right, so the activity series.
Oh, I know what you're talking about. You're talking about the symbols.
Yes, very good. Okay, there's 3 of them, worth 6 points total. Every one of them's worth 2.
Wait, the what?
The symbols.
What symbol? Oh, the little yield symbols?
Yield will not be one of the symbols. Everybody knows that one.
Which, the other one?
Yes, I picked 3 of them. Then everybody's like, what symbols? Yes, and they'll be on the test, and people will look at those and go, you didn't teach me that stuff.
You gonna do, just 3?
Just 3.
I was about to say, Miss Wong.
Just 3, but you don't know which 3. That's the problem. And they won't be solid, liquid, or gas either, or yield. Those 4, I guarantee you will not see. It's the others. Okay? So, make sure you know them, or you can, just take -6. Now, what is the activity series? This is the last thing we have to learn before we take the test. You will need your blue chart to staple together because we're going to use a chart of elements to do this. Now, it's an order in which elements react. We've written lots of equations over the course of the last week and a half. Do all of these reactions that we've written actually occur and react? The answer is no. Okay? I make up lots of reactions on the fly. do all the reactions that we write actually occur and make products? The answer is no. So, how do we know which reactions will occur and which reactions will not occur? Well, the answer to that is the activity series. Now, this is not the only way that we use to decide if some reactions occur or some reactions don't occur. It's just one method that we have to do this. And it's a nice sort of intro way to use in a first-year class to figure it out. It's like the 5 types of reactions we're working with right now. Are they the only types of reactions? No. It's a nice springboard in a first-year class to get started. So 5 types of reactions are a nice way to introduce you to reaction types. And as we get towards the end of the year, we'll bring in a couple more. But again, it's not the only kind of reactions there are. So this is just one method. Now, this is the most note-filled slide in the whole thing. Most of them are examples. So there are 2 ways to read the activity series. All right. Number 1, there are arrows on this chart. The arrows are based on water, acid, and oxygen. So if water, acid, or oxygen is in the equation, you have to use the arrows on the activity series to determine if the reaction occurs. Okay? If you have water and acid or oxygen in the equation, you use arrows on the activity series to determine if the reaction occurs. Okay? The activity series has 4 arrows. 2 of the arrows go with water. Okay? 2 of the arrows go with water. 1 arrow goes with an acid, and 1 arrow goes with oxygen. So if any of those 4 compounds are in the equation, we're going to read this system of arrows to decide if the reaction occurs. Now, do all reactions have water and acid or oxygen in them? Of course not. So there has to be another way to read the activity series. So the second method, if there's no water, acid, or oxygen, what are we going to do if there's none of those things? The element that's by itself. Sometimes I will say, instead of by itself, the element that is alone. Okay, the element that's alone must be above. The element that's alone must be above the element it is displacing in the chart to occur. If it's not strong enough to bump out that element, the reaction does not occur. How do we know if it's strong enough to bump out that other element? It has to be above that element in the chart, excuse me. Okay, some elements are stronger than other elements. Elements that are strong enough to bump out other elements are higher in the chart. That's how we know that they're able to displace other elements. The strongest elements are at the top. The weakest and least reactive elements are at the bottom. All right, is everybody caught up? All right, so your chart is on page 7 of your stapled sheets. Now, some people like to draw in lines like mine. You're welcome to do that if you want to. I don't care if you're drawing lines. Now, for right now, you may also write what I have on the board. All right. So, where it says reacts with cold water. Replace hydrogen from cold water. After we do this a few times, you will know that, and you won't need this by exam day. Because remember, you're going to get a new packet. They're not going to let you use yours. They're going to give you a fresh one that's going to be on that exam kind of paper like the ACT was. All right?
What's that H2O?
Huh?
What's that?
It's an L.
All of that. It's on a chart.
Holy crap.
Oh, sorry.
I just told y'all to turn the page to have that on your blue charts. Okay, you see the activity series? You see where it says replace hydrogen from cold water? Y'all just got to write the little colored part. So when you, because it's not going to say replace hydrogen from cold water. This is what you're going to see, Joe.
What is that in the parentheses?
It's an L.
That does not look like an L as well. Look at upright fish. Right.
And then the other one's a G, right?
How's that?
The other one's a G.
It looks like a 1. That's a G. That does look like a G. All right, so you're going to have this in the equation.
Oh.
It's not going to say plus, I'm going right back, chill. All right, it's not going to say plus cold water in the reaction, right? So when you see this, you have to be able to recognize, is it cold water? Is it steam? Is it an acid? Is it an oxygen? Darlene, try not to slide out of your desk. It's not that bad. So my point here is write this on your table so when you see those, you'll know what the descriptions fit, right? So if you see plus H2O is an L, you know they're talking about which one as well as cold water. If you see H2O with a G, you'll know they're talking about water as a gas or steam. And if you see something that starts with an H, it's got to start with an H, it's what? It's an acid. If it says plus O2, it's an oxygen. Does that make sense?
Yeah.
Okay, now, how do you read the chart? Now, don't do this on your chart. I'm just going right on the board. Does that make sense on what I'm labeling? Now, you can write that on your chart if you want to. You don't have to. Now, if your equation has water as a liquid in the chart or in your question, what section does that refer to? All right, water as a liquid goes with this arrow. All right, it refers to these metals only. Okay, so if it has a metal plus water as a liquid, any of these metals would react with this water and it would react, it would occur. Now, would any of these metals down here react with cold water?
No.
No, you could stick them in cold water out of my sink all day long and nothing would happen. Okay? Magnesium is right there below the sodium, right? The piece of magnesium still laying on my desk where somebody hasn't come and made up their lab. Okay? I can stick it in cold. Well, we'll make the same thing. We use one over here. That one needs to be flushed again. All right? I can stick magnesium in cold water all day long. Anything happen to it? No. Okay? Now, if I heated the water, though, and make it steam, it's going to react. Now, the steam is this arrow. That means all of these metals react with steam. Not just these little metals, but all of those metals. Does that make sense? Okay? Now, if we start talking about the acid arrow is this arrow, right? That means all of these react with that. Now, I don't ever worry about my wedding band when I'm reacting almost anything in here. Where's gold at on this? It's way down here. Okay? These are all fairly inactive. Do I have to worry about the acids I mix or anything else that I mix for y'all in class? No. Even if it gets on my hands, it's not going to interact with my rings. I don't have to worry about them, okay? Because they're way down here at the bottom. Even if I had silver on, it wouldn't make a difference. Now, if I was wearing something else, I might have an issue. But my gold wedding band's not going to be a problem. All right? Everybody with me on that? All right. So, let me clean this mess up. Whoops, that's not what I meant to do. I think that's about right. All right. So, here's a sample like you might see on the test. All right. Now, you have to do two things. The question's worth 4 points. A, 2 points comes from figuring out will it occur or not occur. If you get that part right, you get 2 points. If it's yes, it will occur, what do you have to do after you determine yes, it will occur? Predict the products if it's a yes. You got to tell me what you get. Okay? I know. So, zinc plus water. The first thing you have to decide is, do you have anything that involves the arrows? Because this thing has 4 arrows. We have to decide, do we have to read any of the arrows first? So, do we have cold water? Do we have steam? Do we have an acid? Or do we have oxygen? If we don't have any of these 4 things, then we'll move on to step 2 and learn how to read it that way. So, do I have cold water, steam, and acid or oxygen? We have the cold water. So we're going to start at the top, and we're going to look at just this little section right here. Is zinc in that section? You said no. Zinc is way down here, right? So we write no reaction because you said it's not in that section. Okay? Because it's not in the water as a liquid section, the answer is no reaction. It's not going to make anything. I can drop zinc pellets in water all day long. I do it with my physical science class for a lab. I used to do it with y'all and stopped years ago. Now, what about this one? All right. Is this cold water?
No.
Is it steam?
No. Yes, but yes.
All right, people.
Yes.
Which one of these doodads is steam?
H2O.
H2O is a what? As a gas, right? Does that say H2O is a gas?
No.
That's not steam. All right, what is that? It's O2, so it's an oxide, right? So that's why I said write these things down so you'd know what they were. So since it says plus O2, it's a what? It's an oxide. It's oxygen, right? So we're talking about this arrow right here. That's the arrow that equation comes from. So SN, is it anywhere in that range?
Yeah.
Yes. Okay, so SN is in the O2 range. So since it's in that range, I'm just going to write yes here, particularly for the people who might watch this later who are out today. So the answer is yes. You have to predict the products now. So what kind of reaction is this based on what you've learned over the last week? Single, double, decomposition, synthesis, or combustion?
Single.
No decomposition.
Single.
I need y'all to start putting money on my desk for my alpaca farm. Because clearly I suck at this job. If you think that is single displacement or decomposition.
Synthesis.
All right. Why have we ruled out single displacement here at the last minute? What is single displacement? An element plus a compound. There's no compound. Why can it not be decomposition? There's what? There's a plus sign. Is everybody okay with that? Okay. So when we look at this equation, we have an element plus an element. So that's why it's synthesis. Are we okay with that? Y'all are going to make me suicidal by the end of this test on Monday, aren't y'all?
Sure. Probably.
At least y'all honest. All right, so SN plus O2. Prepare now.
Or would you like this? I just said drink a glass of wine while we live.
Don't take first slice.
I don't like wine. All right, so what am I going to do with synthesis?
You're gonna put them together.
Going to put them together.
And then after that, they'll turn to a compound and you got.
Okay, so they're a compound. I made them a compound. Okay, so I made them a compound. What I got to do if they're a compound? What's O? What's 10? You think? Why do you think? You don't know.
Plus 2. So I can't. So
Okay, it's only plus 2?
no, it's a plus 3 too. Plus 2.
There's on the oxidation sheet, it's listed as a plus 2 and a plus 4. Did I tell you which one to use? No, this is one of those occasions where I said earlier, I didn't tell you, so you could do what? You could do either or, and I would take either one. Since 2 of you yelled plus 2, I'll choose the plus 2. Let them cancel, and that would be our equation. And then you could balance. Now, if anybody had chosen to use the plus 4, would I have marked it wrong? Absolutely not. It would have been fine. Okay? But that's one of those where it has multiple and I didn't specify. That's why all the time when I put on the review sheets or something, I put in parentheses, use the 3, or I write plus 3 in the parentheses, and you're like, Miss Wall, why'd you put plus 3 there? This is why. It has more than one, and I'm trying to tell you which one to use. But in this case, I didn't, so I would take either one. Does that make sense?
Yes.
Okay. All right.
Next one.
That's just the chart. All right. What about that one? You look at the chart and tell me what you think. Don't yell it out. Give everybody a chance to look this time. Look at your chart. Tell me what you think. Not yet. Some people are still writing the question.
I don't know what's going on. Well, say what you think.
All right, Jay, what do you think?
It's an acid.
Okay, it's an acid. So do you think it will react or no?
No.
Okay, I got some head shaking no while you were looking. So if we look back at the chart for anybody who wasn't with you, all right, your acid line is here, right? Here's our acid line. Copper's way down here. Is it in the range? No. So Jade is correct. Okay? Copper is below the acid range. So the answer is no reaction. All right. Try that one.
Is this going to be on the test?
Yes, this is the last 4 questions on the back page.
So when we tell if it's a reaction or not a reaction, do you want us to explain like you do it there?
Nope, I'm just doing it for the people who are going to have to watch the video, or they may not watch the video. I don't care. It's on the test Monday, whether they catch up or don't. All right, anybody want to explain yes, no? Take a shot at it?
Yes, and it's steam.
It's what?
Steam.
It is steam.
Yes.
All right, and I hear yes. All right, so chart back. All right, here's steam. It's this arrow, and magnesium is here. So Tiffany is correct. Are we all okay on that?
Yeah.
Now, I put this one here because I always forget to teach this reaction. This reaction is an exception. Okay, it's a metal plus water. What kind of reaction is a metal plus water, or just this general reaction? Just looking at it, what is it? What does it look like? That part's not an exception. I heard it out there. It's a signal displacement reaction. How do you know it's signal displacement? Compound and element. Look under signal displacement. You'll find it. It's not, that part's not an exception. Okay? What letter is it? B. All right. So, if I do this, just a second here. All right? You get +2, +1, -2. If you signal displacement the way you've learned, you're going to get MgO plus H2, which is the wrong answer. Okay? It's the wrong answer. So, how are you going to fix this? You're going to take your reference table. All right, now, you already know it's signal displacement, right? I told you it's a metal plus water. What's a metal plus water make? What's it say on your reference table? It says MOH plus what? H2. So you're going to fit your formula. So what's the M? Mg OH plus what? H2. Now, this they already gave you. What's this thing? What's the generic word I want? Compound. Element compound. That's what we always use, right? So, what do we always do for a compound? So, +2, -1, bring your 2 down, and you've got the right answer. But a metal plus water is always going to create issues because it's an exception. It's the only exception you're going to run across that we've done. But that one is a pain in the rumpus. Because you're going to predict it wrong. It's possible. Highly probable. Let's go with that. All right. Now, what happens if you don't have any of those 4? Such as one like this. Do you have any water? Any steam? Any acids? Any oxygen? So what are we going to do with the chart if we don't have any of those things? What do you mean by normal or nothing?
Like, just by actually just predicting the other side.
Well, you have to decide if it will occur. You can't just.
Yeah, that's what I'm saying.
Okay. You remember way back at the beginning of your slides. All right. The element that's what? Alone has to be where? Above the one it's displacing. Okay? The one that's alone has to be above. Okay? That's the rule we're going to use. Whoops. Too far. Whoops, too far. There. All right, so who's alone? Okay, so CD must be above somebody. The question is who? How do we decide who CD has to be above? Well, what kind of reaction is this? Why do y'all all look at me like when I ask that question? That's signal displacement, right? So where do we start any single displacement reaction? Oxidation numbers. So what's CD's oxidation number? Okay, what's lead's? All right, look at this formula. What would this one be? +2. And nitrate is what? So who's displacing or switching here? CD and PB. So the rule is the one that's alone has to be above the one that's displacing. So who is CD displacing? PB. So CD has to be above PB. Okay, so if we flip back to the chart, CD is here, PB is here. is CD above PB? Yes. So if you say yes, then you go ahead and displace. So who do we get together on the other side? All right, so CD with nitrate and PB by itself. What do we do to the CD and the nitrate? So plus 2 minus 1, bring the 2 down. PB is alone. Is it one of the 7? Leave it be. We don't do anything to it. All right, last one. Ki plus Cl2. Any water? Any steam? Any oxygen? Any acid? So what you got to do? Okay. So what's K's oxidation number? And I? And chlorine. So Cl, because it's alone, must be above who? Who's Cl displacing? Cl must be above I. All right, check your chart. Is Cl above I? Love when y'all tell me that.
Yes.
Oh, yes, it's above. CL is above that.
So way up there at the very top. All the way to the top of the chart. Okay? Is Cl above I?
Yes.
Yes. Okay? So, since the answer was yes, okay? Since the answer was yes, what are our two products? What are the two products? KCl plus I. What do we do here? Plus 1 minus 1. What do we do here? Because it's 1 to 7. Questions? Any issues? Think we can try a couple?
So wait.
We would. I just figured at this point y'all can balance. Am I assuming wrong?
No, because you only balance so one.
You would balance all of them. I'm just assuming we can do that with these easy ones like that. Because we'd put a 2 here and a 2 there. All right. Whoops. Where are my questions? There they are. All right. See what you can do. You think we can talk about at least two of them? What'd you say about nickel plus water? No reaction. Good. What about the Br2 plus Ki?
Yes.
Yes. Did you predict? What'd you get? KBr plus I2 is good. All right. If you took the time to balance, you'd had a 2 there and a 2 there. What'd you say about gold plus HCl? Anybody get that far?
No.
You got what?
I put no.
No reaction. Okay. Gold is at the very bottom. So if you go to here, okay, gold is way down here. These are your acids. So you'd have no reaction. Anybody get any further than that?
The next one I say, yeah.
Okay. CD plus HCl would be a yes. You'd have CdCl2 plus H2. All right, let's talk homework. All right, you're finishing the sheet you have. And the last one, anybody not have a cell phone? Anybody not have a cell phone? All right, you don't have to take a picture of your homework. I mean, you've got 3 minutes, but all right, but there are the 5 I want you. Isn't that what I just did? That's not what I want. What I do is, oh, there it is. I was going to say, I know I have different questions. Losing my mind. All right, I want you to do those 5 with the activity series. Now, the ones that we just did with the 1 through 12 on the worksheet, do not go back and do those with the activity series. If you did not finish those 12 are homework with predicted products. If I check homework tomorrow, I'm looking for those 12 to be fully predicted, and these 5 to use the activity series. Okay? That would be what I'd be looking for. Those of you who've already done the first 12, you only have those 5. Okay? Yes, sir.
What's something that gold would react?
Honestly, I'd have to look. I'm not even sure what it would react with at this point because that one is so stable. Gold and silver and platinum are 3 of the most stable elements on the periodic table. And if you want to do any makeup work, I will be here this afternoon. So feel free to come by if you need to do that. Test, this is a good day to do a test if you need to make up a test. She's in the auditorium today. All right, if you got a calculator, put it up.